In this video, I will talk about Newton's laws and show you some really interesting illustrations. Although most of us are aware that Newton established 3 laws, which we will discuss in a moment, not many knows that perhaps one of his most original and clever contributions was his distinction between weight and mass. Whereas weight is a number one can measure by a scale and which depends on the acceleration of the object, for instance under the influence of gravity, the mass is an intrinsic property of the object and can be measured by its resistance to be moved. So, if you bring an iron ball and a book up into the space station, you will find that although they both are weightless, the iron ball is resisting movement much more than the book. This resistance is called inertia and is directly proportional to the mass. In fact, one often let the proportionality constant be unity, in which case inertia and mass are the same thing. Now, let's move on to the first law. Newton's first law states the following. Every body preserves in its state of being at rest or of moving uniformly straight forward, except insofar as it is compelled to change its state by forces impressed. In other words, a body is accelerated only by the impression of an external force, and a not accelerated system left to itself will either remain at rest or move with a constant velocity in a straight line. To illustrate this, I have here a cup of water on top of a sheet of paper. Now, if I pull the paper very slowly, then the acceleration of the cup is sufficiently small that the resistance to acceleration is equally small. However, according to the first law, if I accelerate the cup much, it should resist this acceleration enough for the cup to overcome the force of friction and let the paper slip off underneath, just like this. Here is another illustration using a few coins. Or imagine yourself sitting on the roof of a train, as we all do every once in a while, moving with a constant velocity. Suddenly, just as you were to drink your coffee, the train turns to the left and off the train you go. This concept can also be illustrated with this string and coin. At each moment in time, the coin is traveling with a velocity tangent to the circle. So if I let go, the coin continues straight ahead. These are all examples illustrating the reality of Newton's first law. Newton's second law states this. A change in motion is proportional to the motive force impressed and takes place along the straight line in which that force is impressed. This law is perhaps the most well-known of the 3 laws and is often written in terms of mathematics as F is equal to ma, with m the mass and a the acceleration. To illustrate this concept, I have here 2 objects of different masses connected together by a rubber band. The rubber band will now exert an equal force upon the 2 objects, and according to Newton's law, the force 1 is the mass of the big object times the acceleration of the big object, and the force exerted on the small object is the mass of the small object with its acceleration, and these have to be equal. So we can write it as ma is equal to small m big A. So the small object will accelerate more than the bigger. This illustrates the point that the acceleration is inversely proportional to the mass of the object. In a gravitational field, the gravitational acceleration is the same regardless of their mass. This is an observational fact from the research of Galileo. So if you simultaneously drop a feather and a hammer on the moon, where there is no air resistance, let's say a distance x from the ground, you will observe that they reach the ground at the same time. This experiment was in fact performed by David Scott on the Apollo 15 mission to the moon in 1971. You can find the video on YouTube if you would like. So although the force the hammer exerts on the moon is more than that of the feather, their acceleration is the same. Now that you know this, what is the implication for the next time you are on an airplane with turbulence? When you hear the crew tell you to fasten your seatbelts, you know the futility of it, for you will fall with the same acceleration as the airplane, and there is no danger of hitting the roof. Newton's third law states the following. To any action, there is always an opposite and equal reaction. In other words, the action of two bodies upon each other are always equal and always opposite in direction. I have here a balloon, and now it's filled with air. If I let go of it, then the rubber walls, which are now out of equilibrium, will push the air out through the opening, and that stream of air will in turn act on the surrounding air with a force F. According to the third law, this surrounding air will therefore also act on the balloon with a reaction force minus F. Sure enough, there it goes. This is, of course, the idea behind the rocket engine, which ultimately took humans all the way up to the moon. As you can see, these three laws are very powerful. So by knowing them, you know a little bit more what nature is doing to you when you go about your business.